Thank you. Hello, judges. We are here today to present our idea on how we can use data and AI to tackle the marine debris problem, or more specifically, the ghost gear problem. We also have exciting news about partnership that we would like to share with you. So please stay tuned as we give more details through the presentation today.
Marine plastic debris is a serious environmental problem. Once plastic is in the ocean, it never goes away. Ghost gear, the common name for abandoned, lost, or otherwise discarded fishing gear, is the deadliest form of marine plastic debris. Many animals get caught or entangled in ghost gear and can die slow and painful death through suffocation or exhaustion. Ghost gear also damages valuable marine habitat, such as coastal reef and mangroves, and can also pose danger to navigation. The numbers shown here on this slide show why ghost gear is such a critical issue to address. Ghost gear has been identified as a key source of marine litter in the Canadian Arctic, much of which originate offshore. A fact not generally known by the public is that ghost gear act as a vicious cycle. Lost gear often still contain bait, which attracts species. In turn, these species become trapped and become bait for others, repeating the vicious cycle until the ghost gear is retrieved or degrades to a point where it can no longer trap species after years of deadly work. The environmental and ecological impact are very compelling. The economic impact are just as much. It is estimated that 90% of species caught in ghost gear are of commercial value. A 2021 study concluded that lobster trap lost in southwestern Nova Scotia caused the harvest $175,000 annually. I hope you're now convinced that this is an important issue. Our government certainly is, as you will learn about right now.
Canada aims to be a world leader in reducing plastic pollution and in protecting our oceans. We're leading the way internationally with the Ocean Plastics Charter and at home with the Oceans Protection Plan. We're committed to sustaining our blue economy and to protecting our biodiversity and species at risk. Ghost gear affects all of these spaces. It threatens our ocean habitats, it entangles our species at risk, and it hampers our fisheries. On top of this, we've had increasingly common extreme weather events like Hurricane Fiona most recently, leading to increased losses of fishing gear to the sea. Now, with over 8 million tons of plastic pollution entering the ocean each year, we're facing an uphill battle if we want to meet our commitment to recovering 100% of all plastics by 2040. Fortunately, Canada has been investing in fighting plastic pollution by stopping it at the source before it ever gets a chance to reach the ocean, in a life cycle approach we call the circular economy. The Ghost Gear Fund at DFO is a critical piece of this because it closes gaps in the plastics economy arising from the loss of fishing gear by supporting fish harvesters and communities to retrieve ghost gear from the ocean so that it can be returned to owners or be recycled back into the economy. The trouble is, finding gear in the middle of the deep blue sea is expensive and time consuming. That's why we're proposing an AI solution to make it easier to detect ghost gear, which we'll now explore in detail.
So our proposed solution can help to reduce both the cost and the time required for locating ghost gear in cleanup efforts. Our aim is to use AI models to automatically detect ghost gear from different sources of imagery. If we're looking for ghost gear that's floating on the surface of the sea, we can work with optical imagery coming from sources like satellites or aircrafts. And for ghost gear that's submerged under the water, we can use sonar data or optical imagery collected from underwater vehicles. We then leverage AI models to sift through all of this imagery, automatically detect where the ghost gear is located, and report to us those geographic locations. This allows us to derive actionable insights like what types of ghost gear have been detected and where they're geographically most concentrated. So the technical problem domain that we're looking at is the computer vision task of object detection. Given an image, we need to be able to identify what objects exist in that image, and we need to localize them by drawing a bounding box around each one. You can see some examples of that on the slide for ghost gear nets detected underwater and marine debris detected on the surface of the sea. Because the images are geocoded, those detections tell us the precise geographic locations where the ghost gear targets have been found. We can accomplish this using convolutional neural networks, or CNNs, which are state-of-the-art AI models that are used for various computer vision tasks. And object detection CNNs are highly effective, they're widely available in open source code, and they're really general in the sense that we can use them to detect essentially whatever types of objects we have training data for. So the key to making that work in the space of ghost gear is to have large, high-quality annotated datasets that can be used to train these models. Already, we've been able to identify some public datasets in this space, and going forward, we'll seek to gather more data and annotate the data so that we can train effective models. Now, in comparison to an AI solution, standard mapping efforts for Ghost Gear are very labor intensive and they're extremely costly to organize, let alone repeat regularly. As an example, one project which did manual mapping of Ghost Gear for 3 areas in the Arctic cost roughly $635,000 for a one-time mapping effort. Compared to that, a large-scale AI project at the regional level would be expected to cost at most $500,000 annually based on past experience. So this means that with our proposed solution, we would be able to use less money to provide more comprehensive coverage of large areas when mapping out Ghost Gear.
The cost of marine debris to our environment and ecosystem is great and complex as it requires coordinated effort between multiple stakeholders, which makes it even more so relevant to optimize our time, resources, and efforts through the use of AI. Due to the challenges and costs that come with getting and analyzing the data required, many benefits of our solutions are hard to quantify. Yet, through conversation with our partners, we believe that many users would benefit and would be interested by our solution as it would help them in various ways. So while we know it will improve the mapping of Ghost Gear and as such support the Ghost Gear program, it is currently difficult to fund or plan certain initiatives due to the lack of data. So it would bring valuable information for future initiative and just generally at the scientific level, as well as for species at risk. It would also make it easier for fisheries resources management and other stakeholders to deploy resources with this information. Additionally, AI being less invasive, it could also help not disturb certain marine habitats needlessly, while still helping pinpoint the location of lost and illegal gear as well as whale carcasses. It could also answer questions regarding the impact of ghost gear, which have been disturbing our aquaculture and our aquatic ecosystem. And as such, we believe that our solution would benefit all the users highlighted on this slide, and that is without mentioning private enterprises, nonprofit organizations, the fishing industries, and much more. And we believe that by helping them, we will help better protect our environment and ecosystems.
In this presentation, we have identified the challenge and the solution. We believe that we have the team and the partnerships to deliver to this solution. The team is comprised of knowledge leaders from across the GC, including DFO, ECCC, and NRCan. We have confirmed technology and data partnerships from subject matter experts in the related departments, and we have had key introductions to potential NGO and private sector solution users who are willing to participate in this project. Most importantly, as you see in this slide, we have the endorsement and support of the Ghost Gear program at DFO.
Our goal is not to only develop an efficient solution that targets more than one user, but also to develop an ethical one. There are different guiding principles for the responsible and ethical use of AI, and today would like to focus on the human-centric aspect of our solution. So indigenous people communities are disproportionately affected by marine pollution, but they are also finding ways to limit the effect of marine pollution and they advocate for change. And we would like to see this initiative as the first initiative towards developing a two-eyed AI solution where AI sits next to indigenous knowledge to find and assess the potential locations of marine debris and to facilitate and enable Canada's ocean conservation effort. We had an exciting and productive journey so far. Our first milestone was reached on December 2022, and this is when a result fund proposal was submitted in partnership with the Ghost Gear program. The goal is to seek funding for piloting AI solutions for the Ghost Gear problem. Our goal beyond the semi-final is to look for other opportunities for partnership, select a study area and acquire the relevant data, and develop a proof of concept. We will also explore other potential sources of marine pollution, such as floating objects or oil spills. Beyond the challenge, and due to the partnership that was secured with the Ghost Gear program, DFO intends to pilot in partnership with the Fisheries Resources Management AI solutions to detect marine debris and to predict densities of ghost gear. There is certain regions of interest, such as marine protected areas and Gulf of Saint Laurent, so we'll have more closer look at those areas. Senior leaders across the government have called for an action towards the marine pollution problem. They have also taken concrete steps toward this. We are here to enable this for Canadians by the use of data and innovative technologies. Thanks for having us today, and we are ready for your questions.
Thank you very much, team. And I will open it to whichever judge would like to start us off, or I can go in order.
I'm happy to ask a question.
Derek,
Congratulations, really well done. Fantastic presentation. Perhaps I could just ask a question on the sourcing of the data. You mentioned, obviously there's quite a lot of satellite data you mentioned in there. Have you thought of where you'll get the source data for your analysis?
Yep, I can give a hint for this for the short term. So during the challenge time, we will focus on using public data sets. However, in the meantime, in parallel, we are working towards getting more data collected by the Ghost Gear program. We are considering different sources. So right now we are focusing on sonar data collected by third-party organizations and partners funded through the Ghost Gear Fund, but we will also look at other sources such as satellite images or drone images.
Thank you.
Thanks.
I have a question. During your presentation, what came to mind was, is there a link between like this project and then potential results for enforcement of our laws, I guess, in Canada? Because detecting the Ghost Gear is something, but could that lead to also eventually catch the people or the crew or that are contravening to our laws, and is there an impact that way as well?
Sure, I could maybe quickly answer this. Fishermen are required under law to report all lost gear, and there are tagging systems in place to allow it to be identifiable whenever it's recovered. So in that respect, it's less of a catching people as much as remitting to the owner's approach. However, there are cases of ghost fishing where this may perhaps by finding the remains, by finding untagged fishing gear, we could perhaps look at enforcement applications, but we haven't explored those.
Okay, thank you. Yep.
To add to what William said, we have the conservation and protection sector internally at DFO as one of the potential users of the solution. In addition to what William said, there is also another need that the solution can fulfill where it can find entanglement with whales. And this is an area of interest to also conservation and protection sector. Thank you.
Wesley? Okay, Jason.
So I have two questions and a comment, and I'll express all three before I ask you to answer. The first question pertains to the actual scope of what you're trying to do. So clearly you're talking saltwater, but freshwater also has concerns. And so are you looking at both fresh and salt water? That was question number one. Question number two, engagements with Indigenous communities, or First Nations communities that live by the water. And so what are your plans there for ensuring that we work in collaborations with our First Nations? The comment that I had coming from NRCan, we have the Canada Centre for Mapping and Earth Observation, CCMEO, that has a lot of expertise with regards to satellites and AI imaging. So if you haven't done so already, there's Francis. I would encourage you to reach out to the good folks in CCMEO, and I'd be happy to provide contact information if required. Those are my two questions and my comment.
Thank you. Regarding the first question, I would ask Lee about the scope if he has an input there.
Sure, so I can answer a little bit on that. Our focus so far has been mostly on locating ghost gear that would be within the oceans, but there are certainly existing research papers that consider other settings. One of the common areas actually is looking at rivers which bring plastic pollutions into the oceans. So that would be a possible extension of the work using similar concepts, not necessarily for identifying ghost gear, but for identifying other forms of plastic pollutions. But a lot of the ideas and the technology we would be looking at here are quite general in the sense that they could be applied in other areas as well. So if we want to look at things like the Great Lakes or other settings where there could be fishing activity, those would be possible extensions. We just have not considered that at the current time.
Regarding CCMEO, in fact, we have been in touch with CCMEO, and we would obviously expand our work with them to see what the possibility is of leveraging their satellite and LiDAR imaging. The other thing that we have from NRCan's perspective is we have really good relationships with a number of Indigenous and First Nation communities around natural resource development, and we would like to leverage those contacts. DFO has similar relationships regarding fishers and use of gear. So I think between both departments, we have a good opportunity of engagement at that level. And we definitely want those communities involved because they're the ones who actually go out and start retrieving the gear. The purpose of this whole solution is to be able to narrow their search to high value targets.
Excellent. And
Thanks, Francis.
maybe one last comment. The geo.ca is an excellent resource. If you haven't already explored it, I'd encourage you to take a look. All the data sets are free.
Thank you. Wes?
First of all, just wanted to thank you for this really interesting. It's really cool to see you guys thinking about this type of stuff. I have 3 comments that are somewhat related. And excuse me, because I'm not an expert in the field, so if I'm asking stupid questions, I apologize right now. The availability of sonar data. So I can see availability of satellite data. Oh, the oceans are pretty big. We all know that. Okay. Satellite images will cover a lot of the ocean. Sonar data, I'm not as familiar with, so I'm wondering how available is it? Okay, is it readily available to cover the whole ocean? This kind of goes to related to my second question. Do you have a breakdown of the percentage of surface versus underwater? Because if you're using satellite images which have pretty good coverage, you know, you might be better off. Okay, in my mind, because again, I'm not an expert, the low-hanging fruit might be surface first, because you've already got that satellite that covers a lot of the ocean. Again, unless the sonar data is as available as satellite images, or you know, you might want to start with surface. I think would be a good start. And the last point, and it was also mentioned, if you want to do CNN, you need high-quality training data. Okay, so satellite images, your high-quality training data, maybe you might be able to do it with sort of a manual resolution. Your manual figure out, okay, yeah, you know, have some people look at it. That's your training data. The sonar data, I'm not quite sure. Again, I'm not familiar with it. There was a nice picture of some underwater, I think it was a lobster trap or something, going back to my East Coast roots. But that's going to be a lot of work, okay? Because if you don't, you need someone to actually look at it. Is it a rock? Is it actually a trap or whatever? So I'm just curious, you know, maybe the going forward, it might be easier to go for the surface first, which is important. But again, if you know 99% of it is underwater, then I'm curious. Somebody I was speaking to Rio on S. I love this phrase he used: is the juice worth the squeeze? Okay, so if it's 99% underwater, then you know, is it worth going to the surface? Anyways, I again wanted to thank you for it. Really interesting work. If you don't have answers to my questions, that's fine. If I'm way out in left field, just tell me, please.
So I can speak a little bit to the availability of different sources of data that we're looking at. I had done sort of a literature review and search for what is available in terms of what we can grab publicly to get as a starting point. It's true that sonar data was one of the difficult areas to find public data sets that are available. Satellite data is more widely available, and that would probably be the starting point in terms of early prototyping. But there are a lot of cleanup efforts through the Ghost Gear Fund now, which are making use of sonar in order to do manual mapping efforts. So that's a really good source that we can go to try and acquire additional data and then start building up our own data sets that we can use for this purpose. So although nothing is confirmed on this yet, we are already speaking to one group that was funded through the Ghost Gear Fund who do have a large amount of sonar data. So that may be a very good data set that we can potentially work with. It's true that that needs to be annotated in order to produce high quality data to train these models that we're working with. So you spoke about the training data for the CNNs. So we have yet to identify the state of the data that they have, but if necessary, we would certainly look to work with domain experts who are familiar with the manual mapping efforts so that we can leverage that kind of expertise to produce the annotations that are needed to train these models.
Okay, Lise.
Merci. Thank you very much for the presentation. Very good, very instructive. I really appreciate the way you made it accessible for people that are not necessarily as knowledgeable in the domain. I have two very, very quick questions. as Wesley said, oceans are big, and it's likely, and it is a global problem, cleaning up the ocean. So I was wondering if you had, in your research, found other similar experiments happening elsewhere, maybe, or connected with groups that would be doing the same kind of work that you are doing. And secondly, I was wondering if it was considered in your project to use some predictive analysis, maybe to narrow down some of the areas using other data such as current or fishing routes or things like that. So.
Okay, I can speak to the first point. We know that there is similar efforts in Australia in collaboration with Microsoft to locate floating objects using drone images. So that is one similar. We know also on the local inside Canada that there are startup companies that are usually that are already working with the fishing sector to locate ghost gear. So, and they are using also innovative technologies. Beyond the challenge, we seek to collaborate with those startups, maybe through request for proposal or request for information. So that is regarding the first point. The second point regarding other predictive methods, actually, and while talking with the Ghost Gear program, they have another need that maybe the same AI model will not solve. So their need is to predict if there is ghost gear lost, how they will move or how the current will move them to certain region of interest, such as the Gulf of St. Lawrence, to minimize the strikes with whales, or how they float into marine protected areas. So we expect another AI model will be developed, or another predictive model will be developed for this use case, which is to predict the densities of ghost gear in certain areas of interest.
Thank you.
And it will combine the ghost gear data with other environment data such as current and other information. Thank you.
If I might add an additional point, given Canada's landmass and the size of our oceans, if we're able to demonstrate a good proof of concept and then take it further to further development, the opportunity to share this with other countries around the world could be quite substantial. We have experience doing that at NRCan with some of our other models. I don't see why we couldn't do it with this model as well.
Thank you. And I want to follow up on one question because I think you may have an answer for it, but if you looked into the difference, the proportion of submerged versus surface ghost gear, do you have?
Sure. So particularly in Canada, the proportions are definitely much more heavily weighted towards the seafloor, given that a lot of the ghost gear is in the form of traps, lobster pots, etc. So they're starting there. They've already sunk. But there are cases on the surface involving nets, etc. Particularly when it comes, sad to say, but whale carcasses are, a particular sign of ghost gear, and so they'd be one of those objects that we'd be, looking to identify.
Okay, thanks very much. Were there any follow-up questions? All right, thank you very much for your presentation, and I think this is where we leave you.
Thank you.
Thank you very much, judges.
Thanks.
Thank you. Have a great day.